In this video, we're going to plot the motion diagram in A and the motion diagram of C from Lecture 1. This video concerns graphing non-uniform motion. Now let's say you drop something from a hand held high, looking at the motion diagram of A. Object drops, it clearly gains speed on its way, on its fall. Plot the motion as position versus time. Plot those positions, spread out those positions over time of the particle that was falling and gaining speed, and we connect the dots, or interpolate between the dots, assuming the motion between the dots is the same. And we start out with a motion that shows a small negative slope, and then our slope is getting bigger. It's a big negative slope. But what's the slope of position over time? Position over time is speed. So small negative speed, and we go to a big negative speed. The thing is gaining speed. But it's gaining negative speed. It's falling downwards, which we're calling negative, so it's gaining a negative velocity. This is what a curve like this always tells us, a gain of negative speed, negative velocity. Now again we're going to drop the object. Same exact object, gains speed exactly the same way, identical motion. But let's say this time we call the origin at the waist, set the zero at the waist. Still falls from hand to foot. Go from a small negative slope to a big negative slope, same exact motion. Small negative speed to big negative speed. Again, same motion. Going from the hand to the foot, or from the hand to the ground, but this time the origin is at the waist. So still a gain of negative velocity. Same exact situation as before. The slope tells us the motion. The origin is an arbitrary assignment. Whether the origin is at the hand, or the feet, or the waist, still the same motion regardless of where we call the origin. The curve tells us the same exact information. For instance, if we put the origin at the hand, same curve, same motion. Origin is arbitrary. This is still a curve that describes a gain of negative velocity. What if, again, we take that motion diagram and flip it around? We're going from 1 to 6, the non-uniform motion, the gain of motion, but we're saying it's in the positive direction. Going from 1, 2, 3, we're going in the positive direction. Interpolate, connect the lines. We're increasing the slope. It's a positive slope this time, but it's a positive slope that's increasing again. So our slope is still increasing, but in this case it's increasing in the positive direction. Gaining a positive slope, therefore we're gaining a positive velocity. It's an increase in slope, an increase in speed, increase in positive slope, increase in positive speed, gain in positive velocity. But again, that origin is arbitrary. This is still a positive slope that's increasing, which still means a gain of positive velocity. Same exact motion, same exact description. The origin is arbitrary. Get rid of that slope. And what if instead we go from a negative position to a greater negative position, a negative position to a negative position that's closer towards the zero? Still same slope, same motion, gain in a positive slope, gain in positive speed, gaining positive velocity. Arbitrary origin. Now our object is falling but ever slower. Or it could be an object that's going forward or backwards that's going slower. Whatever it is, an object is slowing down. X versus t, put those positions on the x versus t graph here. Spread those positions out over time, connect the dots or interpolate, and we've got a big slope that becomes a small slope. But it's a negative slope. So it's decreasing slope, it's slowing. It's a decreasing speed then. Negative slope, decreasing negative velocity. Again, that origin is arbitrary, so it's still a decreasing negative velocity. It's still something that's slowing down, and it's going in the negative direction, which could be downwards. The negative direction could be towards the west, it could be south, whatever we want to, or could be something that's moving to the left and slowing down, whatever the negative direction of x is. These slopes are the same decrease in slope, same negative decrease in slope, same motion is being described, regardless of where we pick the origin. It simply passes through the origin, or never does, but the motion is still slowing down in the negative direction. Well, here we have a slope that's decreasing also. In this case, it's a decreasing positive slope. This means a decreasing positive speed or decreasing positive velocity. Again, this is something that's slowing. As long as the slope decreases, the object is slowing, but it's slowing in a positive direction. It's something that's moving, say north, or up, or forward, or to the right, or to the east. All those we designate as the positive direction. But it's slowing down. Its displacement is getting less. It's going in those directions. It's slowing in the positive direction. Again, the same type of curve. The curve is decreasing in its slope, so it's again slowing. It's the same motion. The origin is arbitrary. Whether it's slowing away from an origin or slowing towards an origin, that is still slowing. The origin is a matter of choice. So let's review. Here we have a curve that looks like this. It's something that's slowing. A decreasing slope means it's slowing. Any curve that looks like this means the object is gaining speed. What does a horizontal line represent? That's an object that's holding its same position over time, meaning it's something that's resting. And now you've earned a rest too.